All right, guys, so we were on page 6, you said? And we're going to kind of sum up all the transformations that we saw in this chart. Now, we've actually already seen this chart. It was online. Notice the plus C's instead of plus H's and K's. It's exactly the same chart. Got a couple additions in here. Pretty much the same chart. And what we want to really focus on is the differences between column 1 and column 3 as we write these. So in the middle, we're going to describe the transformations. And then at the end, we're going to describe what happens to the points. So if we had f of x plus c, all right, this is similar. If you flip back to page 4, I believe it was, which of the transformations was this similar to? Yes.
Was it b at when you have to add 2 on the outside?
2 on the outside, absolutely. Congratulations.
I had it. I've been looking for that.
Somebody ran out of here carrying it, said they were going to go find you, and then I found it in the hall on the floor. I assumed it was yours. All right, so yeah, this is on the outside, which you said was B, right? And what did we say happens to that one? Shifted up C units, right? Shifted up C units. Now I'm just going to use dittos here because all of these 4 are going to be shifted. And they're all going to be shifted C units. So really the question is just which direction are they going to be shifted, right? So if we look at f of x minus c, which direction was it going to be shifted?
Yeah, down.
Down, right? Subtract c on the outside, shifts it down. Now, what's the difference between row 3 and row 1?
It's inside the parentheses. Yeah.
So in which of those on page 4 does that kind of line up with?
D.
Because it's inside the function, right? And when we say it's inside the parentheses is the parentheses of the function. So it's inside f of x, right? And so this is like having a plus c in the function. Now, what did we say happened with a plus c in the function?
It shifts left.
So,
And what do we say happens with a minus c in the function?
right.
Right.
Okay. So there we go. We've got up, down, left, and right. Now, doesn't need to be there. Describe what would be done to the x and or y coordinates of the graph of f of x, right? So I'll show you how the first one's going to look. We're going to say, listen, x, comma, y becomes something different. And we can kind of copy this first piece down. It's going to be the same each time. And we can actually keep going forever here because this is the same for each of these. Becomes. All right. So now let's take a look at what it's going to become. What's going to happen to the actual points if you had a point at, let's say, 2, 3, right? And you shifted it up C units. What would you do to the point values? Yeah.
X, Y plus C.
Right, you're just going to add to the y value, right? If it was 2, 3, you had to go up 1, it'd be 2, 4. So in this case, it'll be x, comma, y plus c. Okay, what about in the case of down?
Would it be x, y minus?
X minus C.
X minus C, comma, Y?
Yep.
But there was a plus C over here. Now in the first one, we had a plus C, we got a plus C over here. Why is it different in the third one? Why is a plus C getting a minus C? It's inside the function.
Because the H is always attached using subtraction. So it's always represented as the opposite. So plus C is really negative.
Yeah.
And
with minus C, then we're really going to end up getting a positive, right? Absolutely. So it is. It's like an opposite. Trying to see if I can get an orange over here that's a decent one. I don't know if this is going to pop. You guys can even see this. But let's try it. So this will be X plus C, comma, Y. Y'all able to see that back there? Good. All right. I wonder if they could get those to. Oh, the orange is there, but not the purple. I guess maybe it'll work if I hit it again. I'll be able to pull it out. Okay. So yeah, that's exactly it. Now what I would do for you guys, I would go through with my highlighter and I would highlight that note right there. X plus C over here turns into X minus C over there. Because that stands out. That's something different we didn't expect. Okay, in your teams, I'd like you guys to talk about the next two. I got negative f of x, and I got f of negative x. I want to know which one does this go with? Which of those transformations do each one of these go with? And so what do you think the outcome's going to be? What are they going to do to the shape of the graph? I give you 30 seconds. Talk to your partner. Go.
what was it?
What did you ask for? So what do you think?
Okay, negative f of x. I feel like that's too collected. Maybe not. So
Okay, well,
I'm not.
I think we got
Maybe it's gonna outside reflect over the x-axis. I'm not for sure. I need to. Yes, I was right. It was gonna reflect. So I forgot which axis, but I wrote it down. Reflecting for x-axis.
Okay, so let's talk about which one goes with which. Come on, look, there you go. Which one goes with which? So in the first one, we got y equals negative f of x. So Grace, what did you guys find that y equals negative f of x does?
It will reflect it over the x-axis.
Because the negative is on the outside? Yeah. It looks more like whenever we throw that negative on the front of the equations, kind of like in h of x down here, right? When we throw a negative on the front of the equations. So yeah, it's going to reflect it over the x-axis. Good. And then, there we go. Well, what does that mean that f of a negative x is going to probably do, Nathan?
Oh, negative x is going to swap it over the y.
Reflected over the y-axis. Good. Did you have another comment?
I was going to say the coordinate change.
Oh, okay. So what do you think is going to happen on the coordinates?
I think it's probably X negative Y.
X negative Y. Anybody back him up on that? Or got a different idea? Let's just do it in our heads. If we got a point up here, 4, 5, right? I'm a graph, right? If I'm up here at 4, 5, let me draw it up here for my people on the TV. If I got a point at 4, 5, and I reflect over the x-axis, what happens to the coordinates? If it reflects over the x-axis and ends up down here. Does the x value change? Does the y value change? And what happens to those? Annie?
Y value is now negative,
What about the x?
now the opposite, and the x is the same.
The x is the same and the y is negative. So does that agree with what Nathan said? xy becomes x negative y.
Yeah.
I agree. So x, comma, negative y.
And another way around for the next one.
Yeah, so what would happen if instead of flipping it over the x-axis, what if we flip it over the y-axis and it ends up here? Does the y value change? Does the x value change?
It's negative xy.
So the y value stays the same
Yes.
and the x value
It becomes
flips
negative. Yes.
Good. Yeah, I, that's good. Now I got to ask the question that's on your mind. Come on, what's the third question? Look at these and tell me what the next question is.
Why is it the opposite?
What if they're both negative, right? How do we get both negative? And then, now this doesn't actually go here, so don't write this in. But I'm going to show you. I'm asking, how would we get negative x, negative y? It does not go there. Don't write that in. But how would we get that?
There will be a negative outside and
Talk with your partner, and I want you to think about what has to happen to the shape. Okay? If this was a reflect over the x-axis and this is a reflect over the y-axis, is there another type of reflection, translation, rotation? How would we get negative on the x and on the y? See if you guys can figure that out. Give you guys a minute.
Okay, well, for it to be on the x-axis, reflection over x-axis, it has to be negative outside of the parentheses. So I think it has to be inside and outside of the parentheses. Like you see where there's an inside and there's one outside, so it has to be both. Because for this one, if there was a negative y, and for this one there was a negative x, so maybe one outside, but I may be wrong. I feel like I'm wrong. Like it makes sense, but I feel like I'm wrong. I don't know if it makes sense. It might be like a trick question, you know?
All right. So let's get some ideas up here. So we got one. Lulu, what are you thinking?
We brainstormed that since there's a negative on the negative f of x on the outside, and for the reflection over y-axis, there's one in the inside parentheses. We're thinking that maybe there's one on the outside and inside.
Oh, so like a negative f of a negative x?
But we weren't for sure.
Huh? I mean, it follows some logic, right? Negative on the outside, negative on the inside. How about negative on both? Any other thoughts? Yeah.
I think what it would do to the point, like on the graph visually, I think it would like swap into like a the quadrant diagonal to it, you know. So
So quadrant 1 would end up in quadrant 3. Quadrant 2 would end up in quadrant 4, or vice versa. I like it. Any other thoughts on that? What if we drew something real quick, okay? So, if I was to take and make all my positive x positive y's, have negative x negative y's. Unfortunately, it's not easy for me to draw on this. Let's see if I can do this down here and kind of small. If I did this in a quadrant down here, and I made a shape I want to make a shape that we can see the changes really well. So I'm going to make a triangle, because a triangle is one that we can kind of see the way it points a little bit better. Maybe I can do this up in a corner up here where you guys can actually see. So if this is my quadrant, it's a little bit small, and I have something like this, okay, just does not want to draw right. And let's just give it some points here. How about I give you guys the points? It just does not want to draw in these little corners. I needed to make this a little bit better. Let me make my lines a little thinner. Maybe that'll help. So if I change all the values to negatives, so if I start with, like, let's say this is let's say that's like 2, 6, right? And then I make them both negative, what will the new coordinate be? -2, -6, right? So -2, -6 would be like down, down there, right? Yes.
I have a question. Could we be wrong because a negative times a negative is a positive?
Right, I mean, would the negative thing come into play? It's a good question. I'm not saying you're wrong. I'm just asking you guys to think, right? So let's call this one over here like 4, 2. This one over here is like 4, 2. So if I rotate it, then not rotate it, but if I put the negatives on it, what would it be? -4, -2. So it would actually be really hard when this thing does not print where you're supposed to. -4, -2. Now, this was supposed to have it really does not want to draw right where I want it to. It's drawing left of it, and I'm having it's like Annie knows about shooting when your sights are off, you have to compensate, and it's hard because you want it to draw right where you're drawing, and it's like, So, but this is the shape that we're getting. It's literally drawing like a 1/4 inch to the left of where I'm drawing. It's driving me nuts. So here, I'm just going to draw it in what it's going to look like. It would look like this, okay? But I want to make sure you know that this is the shorts. That was right in the middle of it. Not really. There you go. That's the short side there. That's the short side there, right? It rotates. See that? That would be the long side. That would be the long side. So, what kind of transformation is this?
Reflected in the new.
Because if it was an arrow, it would be pointed up over here, and afterwards it'd be pointed down.
So it's reflected in the both axes.
Well, so I'm hearing two things. I'm hearing rotated around the origin by how far?
180.
180. Or, what am I hearing?
Reflected in the new.
So is it reflected and then slid, right? Well, let's see. If it was a triangle and it was reflected, it would look like this.
Oh yeah, that would work.
But what about reflected over both, right? Reflected once, reflected twice.
Mm-hmm.
You guys see how that would work?
Y and then reflected over X. Would that
But
work?
wouldn't they both work?
How could you say it was reflected over the origin?
No, that's a little different. I'll have to show you here in a minute what reflected over the origin looks like. But would they both work? Reflected over the X, reflected over the Y, would that be the same as rotating it 180 degrees?
Yes.
And it would. And you could almost do it with your paper. Take your paper in front of you. Ready? Now look at it when you start, right? I'm looking at a page that says homework, page 7. And it's correctly oriented, page up. Now, flip it over the x-axis. Flip it over the y-axis. Now I'm looking at the same page 7 homework, but it
Upside
is
down.
upside down. Hold on though, which side was the 7 on? I'm gonna flip it back and look, because right now the 7, you know, the binding is in my right hand and the 7's in my left hand. So if I flip it back, the binding swap sides, right? Now let's try a rotation of 180 degrees.
It's the same thing.
So what does that tell us?
It's the same thing.
Yeah. You can get to the same location by multiple paths. By the way, when you get to geometry, you'll break this down a little bit more, and you'll talk about all these transformations as composition transformations. And all transformations can actually be broken down into reflections. I can get any transformation out of 2 reflections. Now, it may take me a little while to figure out what 2 reflections, and it's kind of interesting to try it, but you can actually create a slide out of reflections. How can I make myself slide from here to the door with reflections, right? Well, first off, let me just do it right here. So if this is me, and I want to end up here as a slide, how can I do that?
Flop yourself upside down, like, you know.
Yeah?
Down, flop yourself down.
So I've got a reflection here.
Continue doing that. I guess. Keep hitting yourself.
Yeah, I can do it a lot of times, but I think I can do it twice. Where do I need to put the next mirror? Halfway. Right? Halfway between me, and then that will end up on there, right? So reflect once, reflect twice, and I just created a slide out of 2 reflections. You can break everything down to 2 reflections. Now, how do you reflect diagonally? That gets a little trickier. You're going to have to go over diagonal lines if you want to do it in 2 reflections. You can do it in 4 reflections by going 2 horizontal and 2 vertical, right? But I can actually create it out of diagonal reflections as well. I can make a rotation. Well, we just saw it, right? I reflected over 2 lines and made a rotation. So you can create every single transformation out of 2 reflections. You just have to figure out how to put the 2 reflections where. And sometimes the reflections are lines that are going to be like reflect over this and then reflect over that. And it's going to create like a rotation of 90 degrees. If you put 2 angled mirrors 45 degrees apart, by the time you're done, you'll reflect 90 degrees of reflection on that. Perpendicular. Okay, that was just a little side note, guys, not related to what you're doing. I just thought it was a fun topic to go over. Because we were talking about the transformations and reflections, and I wanted you to see how it's going to relate to your geometry class you're going to be taking shortly after this class, right? So y is equal to the absolute value of f of x. Now, once again, this is another one we're not going to really concern ourselves with in my Algebra 1 class. We'll do it more in my pre-algebra class. We're going to skip this absolute value section. But let's talk about it. What happens to the points whenever you take the absolute value of f of x? Right, so anything that came out as a negative would have come out as a positive instead. So does that mean you're putting the absolute value on the x or the y? Talk to me, partner. Should I put an absolute value on my x or an absolute value on my y? Okay, again.
On both of them.
Right? Wait. I think both.
Yeah, I guess.
Right now. Oh, really? Which one's your best English? Mr. Broussard.
I think you.
Yeah.
Are you doing this class?
Yeah, I'll go.
That's good to be happy. But I think
Is it gonna be hard?
I would
All right, Team Jacob, Team Edward.
Oh.
Team Jacob? Too old? Really? Already? Is
I
that really
understand it, but I just like,
Yes.
yes.
I don't
Yeah,
get it.
exactly.
I don't know who they are.
One
but-
on
Explain
Twilight.
Explain what you mean.
Blunt honesty. Team Jacob, Team Edward, Twilight, you know, there was.
Oh, yeah.
That was back before there was, you know, all these things. I mean, that was kind of one of the initial memes, if you will. Like on the internet, it was all this sending out these Team Jacob little emails. What did we do back then? You know, before the net was what it is now. We actually called it the net. You know, they call it now. So, yeah, we knew what www was. So anyhow, Team X. Who thinks that it goes on X? Absolute value on X. Team Y. Okay, got a couple for Team Y. Nobody for Team X. Team, I don't know. All right.
Is there a team both?
Is there a team Jedward?
Oh, I'm sorry. Team both.
Jedward. Jedward.
All right, let's talk about it.
Yeah.
I'm Jacob.
Let's just talk about a regular absolute value function. Go back to the very front page where your absolute value function is. Now on that front page, we're looking at page 3 for those online. At the very first picture, f of x equals absolute value of x, and look at your data. Now, see if that changes your mind. Yes, but what is always going to be positive?
X.
Why?
Yeah, why?
Why?
No, I'm.
Because why not?
I think it's.
I am.
Because y would be the absolute value of any function, and so y.
And then if you put a negative on the x, you have to divide it by -1.
So let's just think about the shape, right? Let's think about the shape. What is allowed to be negative? Is the y allowed to be negative? Is the x allowed to be negative? Or neither one of them?
The
X is allowed to be.
I mean, because my head is at 0, right? So over here are negative values for x that came out to be positive values of y. So the x is allowed to be negative. But then you absolute value that x and put it in for y. So the y is the thing that actually gets absolute valued, not the x. And it actually makes sense when you read it.
When you're doing that, since the answer is that, you were actually giving us the answer. You're doing the why.
There you go. It's giving you the right. It's giving you the y MCA. Right. But what is f of x equal? What is f of x?
Why?
So it's the absolute value of.
Why?
So this is going to be x, comma, absolute value of y. Still on my very narrow pen. Okay, and so what's that actually going to do to the points? We're going to say it's going to change all f of x to positive. Not the x, it's going to change the f of x,
Which is why.
which is our y. And finally, what happens when we throw an a in front of the f of x?
It stretches that
Right, stretches
many.
or
Or shrinks.
So I'm just going to use stretch by a factor of a, and you'll have to know, that if a is a 1/2, stretching something by a factor of 1/2 would actually be like shrinking it, right? So I'm going to say stretch probably the better mathematical word that they use is skews it by a factor of 1/2, but it's just not a word we use a whole lot. So, but when you get to college level, you'll probably use skew. In this case, we're going to say stretches by a factor of a, or you could say it skews it by a factor. right, and then what's that going to do to my actual x and y? Is it going to multiply the x? Is it going to multiply the y? Is it going to multiply both of them?
X.
Yeah.
Why?
Yeah, we didn't actually write that in there, right? But that's not a horizontal stretch or skew, right? It's a vertical stretch or skew. And if it's a vertical stretch, is it stretching the x-axis or the y-axis? So the x's don't need to be changed. They stay the same and the y's get changed. So this will be x comma a times y. Yeah, I know it's a little unfair, but y gets a little more done to him than the x does. And it honestly makes sense. Think about it. If you have a function, we go back to our regular function. Our predictable function is a remote control. And I'll pretend like this Dymo Electrotag label maker is my remote control. It looks like something off of Spark, you know. Hit me up, Scotty, or it's huge. So, but if I have a button on here, I want that button to do something predictable, right? That's a function. Hit the button, I get a predictable answer. That's a function. But if I want to change what that button does, do I change the button or do I change the program?
Program.
Right, I don't have to go through and take the L button out and put a Q button in. Is that going to do anything? No, not really. But I don't have to change the X. I change what happens to the X that gets a different Y. So it makes sense that we don't change the X as much. We want the X's to be the same, and those outputs would change versus the inputs being changed. All right. Now let's go to the next section. The only difference down here is I'm going to ask you guys to give me the point changes. By the way, we forgot yesterday when we did that previous section. If you flip back to the last page, page 5, at the bottom, we did not underline all the things that were in the vocabulary. Read the instructions for that and find the imperative instruction that we did not do.
On which what?
On page 5, the bottom 2 questions. Emma, what did we forget?
We forgot to state the domain.
State the domain and range. So you guys might want to do that at the bottom of that section because you're going to have to do that on the test. So let's look at those real quick and find the domain and range. With your partner, see if you guys can write that down. Remember, the domain is the list of x values, the range is the list of y values. Please use your parentheses like from 2 to infinity kind of thing, and then we'll do that together.
For the main, I have no, that's not what
It was
Oh,
moving,
okay.
not
So
down,
here.
then left.
And
it was stretching, and so I
yeah, we did that.
I'm guessing.
Basically,
I'm guessing we can.
doing it up there.
Yeah, you take the negative x to positive x.
the main is the range.
Because
All right, who wants to give us our domain for the first one? Lulu?
can you actually first explain how to find it?
Yeah. Find the lowest x and the highest x, and that's your domain. As long as you don't skip anything in between. So lowest x, highest x, and note if there's anything you have to skip in between.
And if it's infinity, then it's the closed or open
Yes.
parentheses.
Right. And if it's equal to, it's closed. So what's the lowest x?
-1, -3.
-1 is the lowest x. What's the highest x?
Infinity.
Infinity. And remember, how do we remember which one goes with which? Domain or range?
Y.
Alphabetical, right? X is before Y, H is before K, domain is before range, input is before output. The only one that doesn't work was independent, right?
And then for range, would it be -3 with a closed parenthesis?
Yes.
And then infinity.
So much better than my previous attempts at trying to explain it. The boys go out on the range, and the boys have Y chromosomes. That shit was awful. I slapped myself the first time. I was like, boy, that is so simple. All right, 1, 3, and this is upside down because of the negative, right? We already did these.
So domain is -infinity? Yes. -infinity.
All right, somebody else want to give us our domain? Grace? 1, infinity. And range, somebody else? Hasn't gone yet? Okay, Annie?
-infinity to 3.
So should the negative infinity go first or second?
First.
You guys agree?
Yes.
Nathan?
I think this is for range.
No, because the greatest number goes
It should be
on the
Shouldn't it
next
be
greater
0
than
to 3?
infinity.
Or like 603.
Does it go below 0?
No.
Is the if I was to put in, let's put in a 10. What's 10 minus 1?
No.
Square root it.
-3.
Well, 3. Throw a negative in front of it. -3 plus 3 is 0, right? Okay. But what if I put a 26 in there? 26 minus 1 is 25. Square root. -5 plus 3. So is it going to keep going down? So is it going to go down forever to negative infinity?
Yes.
And as Lexi did tell us, you always put the lowest number first, higher number second. I just want to see if any of you guys are right? Very common mistake people will do is write 3, negative infinity. You just always put them in order from least to greatest, whatever you're writing this. Okay, so let's move on to the next section of it. And those last 2 problems or 4 problems that were there were ones that we just want to write down right there. We want to write down what they've asked us to do. I believe this one they want us to put the points on it. It says describe how the graph of each of the following will be different from the basic function and graph the given functions. And so, I mean, once again, you can do the same descriptions we've been doing of the transformations. This one's going to be what? Down 3, right? Shifted down 3 and shifted what?
Left 2.
2, left 2. Now, I don't want you guys to cut it off that one. I want you to put shifted left 2. Then what about the XY coordinate version of that? X comma Y becomes what?
X minus 2, Y minus
Exactly. And then we would just graph it, and it would be at -2, -3 down here. And that's where our function is. So do that for all 4 of these. You're just going to talk about what happened to the, and take the negatives off if there's a negative on the x. Take the negative off. We're not going to deal with those negatives on the x in this class. So just deal with it with a positive on the x and graph them and tell me the three things. Tell me the things that happen. Give me the points for it. And then graph the final graph. So let's do this. H of x, f of x, and p of x. And the things that we have to do are name the function transformations, point, and graph. So let's do this. H of x, you guys name the transformations that are going to happen. H of x, you guys give me the point that describe like x, y becomes what, and you guys are going to graph it. Okay?
So it's going to
F of
be
x, y'all are naming the transformations. You guys are going to give me the point.
so let's
And let's do this. Between the two,
so let's choose
I'll graph it. You guys on P of x, name the transformations, and give me the points.
P of x?
And I'll graph it.
But you
Actually, you got you two can graph all of
P of x.
them. They're my graphers. So when
describe
they're
it.
ready, H of x, you guys will come up.
Describe the transformation. Yeah. Remember, remove the negative on P of x. Give the points like on the table. I'm not sure. Give the points. Mr. Conaway, when you say give the points, do you mean like do an x and y table?
No, I mean give me the x, y becomes what?
Oh.
All right, let's go with H of x. Tell me whenever you guys are done with. You don't have to graph it. You just have to tell me what
The
transformation.
cube doesn't alter anything.
Like it's up
Okay.
one,
This is like the
three.
cube.
Oh,
Okay. That's all it does.
So what do you think? So reflected across the
Make sure it's
four
P of x.
and
Well, graph that we have to do.
so
Yeah, just don't do the x's and negatives.
So let's just say up four.
Okay, H of x. Tell me your transformation.
Up four for one.
H of x there in the front.
up four. Reflected across the x-axis and a right one. I think.
So plus one on the inside. Does that show up as a right one? I heard a question back here. Are we good with that? Shifts up four, flips over the x-axis and goes right one. Do you agree? Agree. If not, then no, let's move on. Agreed? All right. Okay, then let's, next is the points. What happens to the points?
So we had a little bit of trouble with this.
Uh-huh.
But so we know it changes y to positive.
Okay? So x comma y. Let's think about all the things that happens to it. It changes y to positive, right? Or sorry, well you should say that we put a negative in front of the y, right? But then what about the shifting up and the over? When does that happen, right? Remember, we're always going to reflect first. You want to reflect your shape right at the beginning and then slide. So we're going to put the negative on the y. And is that what you were saying? Like that, negative y plus 4?
Yeah, I didn't know if it was in parentheses.
That's what I was saying. Because if you do it in parentheses, then you're actually going to make it negative y minus 4. You see what I mean? Well, when you distribute it. So, okay. And then what about the other one?
X minus 1.
Nathan Nathan over here is questioning something. Nathan, what are you questioning?
For the transformations that you put down, it should be left one because the plus one doesn't mean you're adding it to it because the h, which is the one, is it's already subtracting, so it has to be negative if it's plus. I don't know if that makes sense.
Right. We said that when it's inside, it goes opposite. So plus normally would go right, but when they're inside, they go opposite. So that's actually going to be left one. Yes, you're correct. And that x minus 1 is correct there. The negative y plus 4 is correct. And gentlemen, can y'all graph this for me, please? Yes.
Why would it be plus 4 instead of minus 4? To the negative y.
Well, let's take a look. Let's wait till they graph it and let's see what happens. Now, did y'all? Yeah, you can't put your hand on the screen. It will freak out.
Why did we pick the shortest person to do this?
We gotta make it about high. All right. There you go. Let's check and make sure that this works. Now, did we graph this on a graphing calculator, Winston, or you guys just figure this out from the transformations? You ever want to check it? What should you do? You could use graph calculator, but what if it's a non-calculated portion of the test? You can table it out, right? Let's just test a couple points. We don't have to have it do a whole table. There's a point. How about 3, 0? 3, 0 shows me it should be on there, right? According to the graph. Let's plug in 3 and see if we get 0. So what's the absolute value of 3 plus 1?
4.
Put a negative on it.
Negative 4.
Plus 4.
0.
We got lucky with 1. Now, let's try at least one more. If we get lucky with 2, I'm going to try one on the other side. So how about negative 1, 2, 3, 4, 5? Is that what it is? Negative 5? So let's plug, and that's a 0. So if I plug in negative 5 to x plus 1 there, right? What's negative 5 plus 1?
Negative 4.
Absolute value. Throw the negative back on it that's in front.
Negative 4.
Plus 4 is
0.
I think we've got it in the right location. Now let's make sure everything looks like it lines up with what we said. So our original graph, our parent function, should be this, right? Oh, that was awful. Has this been reflected over the x-axis? Has the black one been reflected over the x-axis from the green one? Yes. Was it shifted left one from the green one? Yeah, the tip of it, the vertex is there, the vertex is down there. That's left. Has it been shifted up for? Yes. So I agree with all those statements so far. Does an xy become x minus 4 and comma negative y plus 4? Well, here's where we test it. Pick a point. Pick a point. I'm going to pick one point. How about this one? 2, 2. Now, if I plug that in, I should get 2 minus 1, comma, 2 minus 1, comma, negative 2 plus 4. So I'm plugging in 2, 2. Let's find out if this works. What's 2 minus 1? 1, comma, 2. Was there a point at 1, 2? Yes. 1 is luck, right? Let's try it twice. How about 0, 0? If I plug in 0, 0, would I get negative 1, 4? Well, negative 1, 4 is right here. Does that look like where 0, 0 is moved to?
Yeah.
So the points x, y, 0, 0 gets moved to This is like the recipe for how to move all the points, right? If you were going to if this was like an archaeological dig, right? And you had to come in there and you had to cordon it off into all those little sections, and you were going to recreate it in the museum, right? So that you guys could go back through it, right? You know they actually do this with plane crashes. They literally go through there and they XY map it, chop it up into pieces, and they carry every section back and piece it together in a big hangar somewhere, exactly the way they found it, so they can map out what happened. Because they can't leave it out there. Rain's going to come, wind's going to blow it. They want to put it in there and they can map out exactly what happened. And if we were going to do that, this is the process for doing it. Move every one of these points to these new locations. Yes.
The only thing I don't understand is why it's a negative y plus 4.
Well, let's go back to the topic, what we just wrote down today. Y equals negative f of x. How does the point get changed? But what's the xy becomes what?
X coming
There's where the negative comes in. So it's kind of like I'm adding those two together. I'm taking that row that says change it to a negative y, and then I'm taking the top row that says add 4. Now the only rule you do need to know is we always reflect before we move. Okay, put the negative on the y before you put the plus 4. Because otherwise you're doing what Annie said, how do I know it's not negative parentheses y plus 4? We would reflect the shape before we slip it. Yes. Absolutely. All right, go. You guys y'all knew how to do the other two. Let's quickly run through those. I don't want to spend too much more time on this. On on f of x, remember that that we're going to get rid of the negative. So let's just talk it through. What were the transformations? Who had the transformations for f of x? What'd you guys get? Down 3, I agree. Left 2, I'll take it. And then that's a cube root. So down 3, left 2 is here, and a cube root. You got to go over to 8 before you go up to 2 or something. So it's like something like that. It goes really far. All right. So that's a cube root, guys. And then the question is, what's going to happen to the xy's? This one's nice and easy.
xy becomes x minus 2, y minus 3.
Now, if that negative x had been in there, that would have been a booger. Because it throws a monkey wrench in there for us. But this is good. Okay. P of x. What did you guys have?
The transformation inwards.
Yes.
We had shifted left 4 units and shifted up 1 unit.
Right, because we're getting rid of that negative that's on the inside. It's not really there. So I agree, left 4, up 1. And then what's the xy going to be?
X minus 4, and then y plus 1.
And that would be left 4, up 1, and it's a cubic, not a cube root, so it's going to go something like this. Just a quick drawing. All right. I guess we'll let her back in. She seems like a nice person. Let's take a quick moment to look over our homework. Make sure that we have on page 7. See if there were any questions on that. Now that we've done this. Remember, you were going to drop the negative on number 2.
Yeah.
I would suggest that you guys add on, now that you know about the parentheses thing, I would suggest you go through and add that on for each one of them. The XY becomes what? Make that the second part of your homework for tonight. That's going to be the only homework you're going to have, is to add that on. Okay?
To what?
To add that on.
I don't have room, so can I just like put post-it notes on that all?
Yeah, that's totally fine.
Okay.
All right, now let's talk about what we're going to skip here, because I didn't realize that when I printed this that there was a piecewise function section. We're not going to deal with piecewise functions today. We're not going to do them now. Let's not, scribble them out. We might come back to them when we get into when we get into spring semester. We're going to skip all the way to page 13. Computations involving function notation.
Are these notes?
And this is notes again. Remember, your homework has boxes around it. Has double bars around it. Now, skip the homework on page like 11 or something. Page 12, whatever it is. We're skipping the piecewise defined functions. We're skipping the absolute value graphs. We are moving on to the notations with functions. Function notations. Now, we talked about this back in the day, and I told you guys that there were three things that a f of x tells you. So if I told you that f of -4 equals 2, you should be able to tell me three things from that piece of information. Three pieces. So with your partner, I want you guys to look at the notation. F of -4 equals 2, and come up with three things that you know about this function.
Yeah.
Okay.
Didn't have anything else. Then yes, we do know something else. Well, f of x.
Dry eyes. I haven't been taking my allergy meds.
If it is true, then we should have y.
F times -4 equals y. Well, no, the f of x is in multiplication. It's just a label. You do not multiply it.
Okay, let's come together up front. I need to know three things. Somebody who hasn't answered yet today. There's a couple of you. Come on, Wonderade, what you got? Give me something.
I've answered today.
Oh, you have? Okay. Austin's next. And Sarah. Cooper, what you got?
One thing that I have is x equals -4.
X equals -4. Good way to jump in there and get that one right before Austin has to come in. Austin, what do you got?
I've got f equals 0.5.
Well, I don't need you to calculate anything. This should be something you tell me just by looking at it, and it should pop out like that. So x is equal to -4, for instance. That's one of them. Sarah? What does the 2 tell you? Y is equal to 2. Good. X is equal to -4. Y is equal to 2. One more thing. Anybody? Grace?
If you were to graph it, it would be reflected over the y-axis. Right?
Are you thinking because of the negative on the 4, it looks like -x? I like your thinking. But only use that when it's actually an x, not whenever it's a number. This is a specific point, and it's the point -4, 2. But that point goes where? What is, there's a third thing that, what's the only other thing in there besides the negative 4 and the 2? F. What does F tell you? More than that. What if it was Q of X? What if it was P of X? What if it was G of X? What if it's H of X?
F times negative 4 equals.
It's not times. It's F of. It's a label. What did the label? What was
This
the
is function F.
function F? What function is it not?
Function.
It's not function W. It's not function Q. Up there, I wrote another function to help you guys remember. What function do I not plug it into? I don't put it in a G, right? It's F of X. So I go to the function label. Literally, that's all it is a label. You go to class 419. You don't go to class 420, right? You go to the classroom that the label's on. This is just a label, F. It doesn't have any mathematical value at all, right? Just a label. It tells you which function to go to. Yes, we will have I'll have a page with 3 functions on it, F, G, and P, and I'll say F of 3, and G of 2, and H of 1, or P of 5, or something. And you'll have to go find the right function, plug in the right X, and give me back the right Y. That's all you know. So you know 3 things. You know what is X, what is, right, which is negative 4. Which equation we plug it into? F of X, right? Not G of X. Don't need that. And then I'm going to find out what Y is, okay? So let's plug it in. F of negative 4 is equal to negative 2 times. Right? And now, and bada bing, bada boom, F of negative 4 is equal to 2. You do 3 things, right? Remember that starting tomorrow, guys. We will be doing composition of functions, and we should be able to get through that chapter and get you guys to some homework for that. Adieu!